Hello, hello. Since listening to GEM's album Revelation, I decided that I liked the songs so much that I now want to go back to all the songs and analyze them more in depth from a music theory perspective. Now, to be honest, I am also a beginner in music theory. I've only started looking into the stuff in the last few years, and I've never taken any formal theory lessons. So I am treating this like a learning experience. I'm probably going to get a lot of stuff wrong. I'm probably going to miss a lot of stuff, but that's okay. That's part of the fun of doing this whole exercise. And I hope you can find some of this content interesting as well. Before we get to the songs, though, we have to do a quick 5-minute crash course into music theory. So if you look at the piano keyboard, you can see that notes are laid out in a repeating pattern. So from here to here, this section, you can see that it's comprised of 7 white keys and 5 black keys sandwiched in between. It's actually repeated over here and again on the right and more on the left. The interval from the start of one section to the start of the next section is called an octave. And there's actually a physical relationship between notes across an octave in that the frequency of sound produced by this note is exactly double the frequency of sound produced by this note. And the same thing is true for the next octave. So the frequency of sound produced by this note is again double the frequency of sound produced by this note. Within each octave from here to here, you can see that you have to go across 12 different notes. So starting from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In modern Western music, especially in pop music, all of these 12 notes are spaced equally apart. And that's on a logarithmic scale. So what that means is if you want the frequency to double from here to here, you need the frequency to increase by a factor of the 12th root of 2 from here to here. And again, from here to here, it increases by a factor of the 12th root of 2. And if you keep multiplying over these 12 steps, by the time you get to here, you get exactly twice the frequency of the original note. And because everything is spaced equally apart, what that means is you can actually start with any note. You can start with this one, for example, and if you do the same thing and go up by 12 of these steps, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then you get another interval of an octave where the frequency of this one is still exactly double the frequency of this one. Each of these small intervals, that is the interval from here to here, or the interval from here to here, is called a semitone, or annoyingly a half step. And because an octave is divided into 12 half steps, that means there are 6 whole steps across 7 white keys within an octave. Yeah, don't ask, musicians are not engineers. Another interesting interval is from here to here. This is called a perfect fifth because 1, 2, 3, 4, 5, and it's comprised of 7 half steps. This interval, if you calculate the relationship in frequency, you'll get the 7th power of the 12th root of 2, and that happens to be very close to 1.5, or 3 halves. And because this is a very simple fraction, or very close to a very simple fraction, it sounds good to your ears. And this is the basis of a lot of chords that you hear. Next up, we can talk about what these notes are called. Colloquially, or if you're trying to teach music to children, you typically start with names for the white keys like so. Do, re, mi, fa, sol, la, ti, do. And that's where the song do, a deer, a female deer, re, a drop of golden sun. That's where that song comes from. But if you want to sound professional, and in music theory circles, we don't use those names, we use letters instead. So do is actually called C. The next one is D, and then you have E, F, G, and after G, it doesn't go to H, it starts with A, B, and back to C. Again, don't ask why it starts at C. There are historical reasons for that. And incidentally, historical reasons is also why the first hard disk on your Windows computer is called the C disk. But anyway, those are the names of your white keys. Now, the black keys don't have explicit names, but you can name them in relation to the white keys. So this white key here is F. And this black key is just one semitone higher than F, so we call this F sharp. Sharp means one semitone higher. And similarly, because this one's called G, you can also call this black key G flat. Flat means one semitone lower. And this is true for any note. It doesn't have to be a black key, so you can call this, technically this is F, but you can also call it E sharp. And E can be called F flat. And in music theory, sometimes that is done for technical reasons. Next up, we have scales. So the most simple, the most common scale that you find in Western music is the major scale. And that's the scale used in the Do Re Mi song. The scale goes like this. This is called the C major scale. C because the first note of the scale is a C, and major is defined by the intervals between the notes of the scale. So if you look at the interval between the first and second notes of the scale, it goes through 2 semitones. Between the second and third note, it goes through 2 semitones, but between the third and fourth note, it only goes through 1 semitone. And if you count the pattern all the way across, you get 2, 2, 1, 2, 2, 2, 1. And this will be the same pattern for any major scale. So if you want the F major scale, you would start with F, and then again you would count 2, 2, 1, 2, 2, 2, 1. So the F major scale goes. As another example, if you start from, for example, E flat, then you would still count the same intervals again. 2, 2, 1, 2, 2, 2, 1. So the E flat major scale would be. Another common scale that you'll find is called the minor scale, and the minor scale goes like this. So if you count the interval, it's going to be 2, 1, 2, 2, 1, 2, 2. Or you can also think of it as the major scale, but you take the 3rd, 6th, and 7th notes and you flatten all of them to get these. Typically, to music theory beginners, we usually introduce the major scale as something that has a happy, upbeat mood, whereas the minor scale has a more sad, melancholic mood. And of course, those are not the only possible scales you can have. You can take any combination of intervals and make that into a scale. For example, we've seen the pentatonic scale, which is a whole different set of intervals. And finally, there's the concept of chords. A chord is basically just multiple notes played together at the same time. And the way they're named is based on the scale that they're using. So again, if we take the C major scale and we take the 1st, 3rd, and 5th note of the scale and we play them together, this is called the C major chord. It's the same thing if we take another scale like E flat. If we take the 1st, 3rd, and 5th notes from the scale, we get the E flat major chord. And of course, we can do the same thing with minor scales too. And if we take the 1st, 5th, 3rd, and 5th notes, we get, this is the C minor chord. So compare C major, C minor. Doesn't this one sound happier? And this one sounds sadder? All right, I think that's all we need to know about music theory to get started with the first song, Gloria.